In this section, we'll talk about producing messages to Kafka using the command line tools. We'll explore key tips and best practices to make this process efficient. So why use the command line for producing messages? It's quick, easy, and ideal for debugging and testing. For example, you can simulate data flows for NFT testing, verify broker connection, and validate ACL configurations with ease. To keep things simple and efficient, we will use a Docker setup with Zookeeper, one Kafka broker, and Schema Registry. You can see an example docker-compose.yaml file in the next slide that we will use for this demo. This Docker setup defines three services: Zookeeper, which coordinates the Kafka cluster; Kafka, our broker service that handles the message production and consumption; Schema Registry, which stores and serves Avro schema for message validation. This setup allows us to test message production effectively with the necessary services in place. After saving the file, you can start the services with docker-compose app-d. Now let's dive into how to produce messages. If you don't specify a key, Kafka will distribute the messages across partitions using a round robin or its internal algorithm. But if you include a key, you will have control over how data is distributed, ensuring messages with the same key end up in the same partition. Before producing any messages, we need to create a topic. For this demo, we'll use a payment topic with two partitions and a replication factor of 1. This configuration is ideal for testing in a single broker setup. We will use Docker exec to access Kafka CLI tools from within the container. This allows us to run commands directly in the container without needing to be logged in. For example, to view the Kafka topics, you can run the following command. To create the payment topic, use the command given on the screen. This command creates the topic with the specified number of partitions and replication factor. Now let's look at what happens when we send messages without using keys. This is the simplest way to send data in Kafka, but it has some important implications. When you don't provide a key, Kafka takes care of partitioning the data for you. How does it decide? Well, Kafka distributes the messages to partitions in a round-robin fashion, or it might use its internal algorithm. Essentially, Kafka balances the load evenly across all the partitions in the topic. You can use the command given on the screen to send messages. Let's talk about sending messages with keys in Kafka. So what's the deal with keys? Think of a key as a kind of map. It tells Kafka where to place your message, specifically which partition it should go to. Without keys, Kafka distributes messages round robin or random, but with key, you gain control over the message distribution. Let me show you how this works. We'll use the Kafka console producer to send messages to the same topic payment. This time, we'll include keys with each message. To do that, we need to set a couple of properties. First, we will enable pass.key equal true. This tells Kafka that the messages include a key. Then we'll set key.separator equal colon to define the character separating the key from the actual message. Watch what happens when we send the first message. So here the key is 1, and the message contains the user ID, the amount, and the currency. Because the key is 1, Kafka will map this message to partition 0. Now let's send another message. This time the key is 2, and with our setup, Kafka will place this message into partition 1. So the key controls which partition each message goes to. Let's talk about schemas in Kafka. Now you might wonder, why do we even need schemas? When working with Kafka, data doesn't just fly around randomly. It needs structure. That's where schemas come in. In Kafka, schemas help define the shape of the data you are working with. For example, you could use JSON, Avro, or other formats to define how your data is organized. think of a schema as a contract between producers and consumers. It ensures everyone agrees on the structure of the messages being exchanged. Today, we're focusing on Avro schema. Avro is widely used in Kafka because it's compact, fast, and integrates beautifully with Kafka Schema Registry. The Schema Registry is like a database that stores these schemas, ensuring that your producers and consumers are always on the same page. It prevents mismatched data from causing chaos. On this slide, we'll cover three key things: how to define an Avro schema for our payment data, how to produce messages that follow this schema, and finally, how to troubleshoot schema validation issues, which can happen if the producer sends data that doesn't match the schema or if there's a version mismatch. Let's get started with Avro schema example for payment. We'll see how it defines fields like user ID, amount, and currency. Then we'll dive into the practical step for producing messages that adhere to this schema. We'll first need to ensure that Schema Registry is up and running in our Docker setup. You can verify that it's running by checking the list of containers, or you can also check the available schemas on the Schema Registry by running the second command. Next, we'll define an Avro schema for the payment topic. Here an example schema that we will use. Once we have the schema, we need to register it with the Schema Registry. You can run the command on the screen to do that. Let's walk through sending messages without a key but using a schema. We use the Kafka Avro console producer.sh command to send messages to the payment topic. This producer works seamlessly with the Avro serializer, which enforces structured data format. First, we need to specify the Bootstrap server to connect to our Kafka broker at localhost 9092. Next, we define the Schema Registry URL using the --property schema.registry.url option. This ensures the producer knows where to validate and store our data. The schema itself is defined inline using the --property value.schema. Let's take it a step further by sending messages with a key. In this example, we'll combine the power of keys for partitioning with schema validation for data correctness. To send messages with a key, we add a few more properties to the Kafka Avro console producer.sh command. The property pass.key equal true tells Kafka to expect keys in the input. The property key.separator equal colon defines the delimiter between the key and the value. The schema is still defined using the property value.schema. The structure of our payment record remains the same, with fields for user ID, amount, and currency. In this case, key 1 is sent to partition 0, key 2 is sent to partition 1. The schema ensures all messages conform to the expected structure, preventing errors downstream. By combining keys and schema, we achieve both efficient partitioning and data validation. There are a few common errors to look out for when sending messages. Make sure the message data matches the schema. Ensure that your Kafka broker is running and reachable. Verify your topic configuration before sending messages. Let's see what happens when we try to send a message with a schema that doesn't match the Schema Registry. In this example, the schema we are defining has a user ID field as a string instead of an integer, which is different from the registered schema for the payment topic. The Avro serializer checks the message against the schema in the Schema Registry. Since the user ID field doesn't match the expected type, the producer throws a serialization error. This ensures that invalid data is never sent to Kafka, maintaining the integrity of the messages in our topic. It's a great example of how schema validation acts as a gatekeeper for data quality. No message will reach Kafka in this scenario, protecting the consumers from handling bad data. Schema validation is a critical part of ensuring data consistency. The producer uses the schema to validate the message before sending it to Kafka. The Schema Registry enforces compatibility rules and ensures that the schema remains consistent. Kafka, on the other hand, stores the serialized messages but doesn't perform any schema validation. If you're facing issues, ensure that Schema Registry is reachable by running the following command. Check your producer logs for any serialization errors. Check your producer logs for any serialization error and test message the serialization on the consumer side.